if we're looking for angular acceleration, oops, that's frozen, all right? If we're looking for angular acceleration, then what we want to know is how can we find the answer to this when things aren't constant? We have some change. We had the disk moving at one speed at one point, one speed at a later point. We had change in the distance to the center of rotation from where the laser was. Like there's all this stuff going on. And you know what this is? This is a kinematics problem. So let's think about what's happening at the start of our time period. At the start of our time period, we know that the disk has an angular speed of 48 radians per second. 80 minutes later,
that's what it looks like before.
It has an angular speed that's less than that. It's 20.7 radians per second. We have some velocities, we have a time, we're looking for acceleration. This is kinematics. Let's make a variable inventory. We already know, the way I've drawn it, that positive is counterclockwise. So let's say that we have an initial position, let's just say it starts at position 0. We could say that. And what does it end at? We don't know. I don't know how many times this spins around. I don't know how many radians it moves through. Its initial angular velocity, I do know, it's 48 radians per second. Its final angular velocity is 20.7 radians per second. Don't know the acceleration. The amount of time that goes by, well, it's 80 minutes, but there's 60 seconds per minute. And since all of our speeds are in seconds, we want to make sure that our time is in seconds as well. And we have a solver to do this. We can put these numbers into our kinematic solver. Initial position of 0, final position unknown, initial velocity is 48, final velocity is 20.7, acceleration is unknown, time is 4,800 seconds. We're looking for acceleration. We have an equation that will tell us the acceleration with that information. It's about negative 0.0057, and that makes sense because it was moving in the positive direction and it's slowing down. So its acceleration, angular acceleration, should be negative. And it's negative 0.0057 radians per second squared. Here's the next piece. If we want to know the tangential acceleration of a point that's 58 millimeters, or 0.058 meters away from the center of rotation, this is not a kinematics problem. No time is going by. We don't have different velocities or locations. This is merely a matter of switching from the angular realm, where the acceleration is the same everywhere on the disk, to the linear realm, where the acceleration will be greater the farther away you are from the center of rotation. Tangential acceleration is going to be equal to alpha times r. Alpha is our angular acceleration, r is distance to the center of rotation. That's negative 0.057, oops, 0.057 radians per second squared times 0.058 meters, and that ends up being some sort of a really small number.
Yeah, like
0.058 times 0.0057 ends up being about
.000.
negative 0.0003-ish meters per second squared. And if you do the units here, you'll realize the actual multiplication would give us radian meters per second squared, but a radian is a unitless ratio. So we can just ignore it now, pretend it's not even there, and we get meters per second squared. Here's just real quick and then I'll get your question. What I want to come back to is all of this stuff should allow you to solve a problem like this. If we know that my crank has a, from the crank to the pedal has a radius of about 0.1 meters, about a decimeter, 10 centimeters, and the gear has a radius of about 8 centimeters. I'm making all these numbers up. And the rear gear has a radius of about 0.04 meters, and the bike tire itself has a radius of about 0.31 meters. Then you want to be able to tell me how far this bike will go if I pedal once all the way around. Forget about coasting, right? Like no coasting. And this is the same thing that we just did. It's the same thing. And you ought to be able to answer a question like, what will the RPM be of your pedals if your bike accelerates at 0.51 meters per second squared for 31 seconds with an initial velocity of being at rest? This is not that tricky. It looks tricky because there's all this stuff, but really it's just a matter of finding the angular acceleration of the back wheel, figuring out the resulting linear acceleration, the inner gear, figuring out the resulting angular acceleration of the cranks. Like, it's all doable, but it really takes a lot of thought. So this is what I would like you to be able to do. Some of you are making great progress. Others of you are a little off, so just like keep that in mind. It's not the worst thing in the world for you to take a few minutes and think about some of this stuff. Like this, do this. If you come in next Thursday and you were able to get this done, that's great. You're in really good shape. If at this point right now you couldn't do this, then I would like to help you. So we could talk about it. You can email me. You can come in. I would like to help you work through this, but this is sort of the target to be able to get to this. All right, enjoy your afternoon.